You may have heard people talk about our lizard brain. They will of course have been referring to the part of the modern human brain situated right at its base that we inherited from our distant reptilian ancestors. It seems evolution tends not to redesign what is already there. Instead, it adapts to ever-changing needs and circumstances by adding additional parts to existing ones. This process has undoubtedly been the case with our human brain. New regions gradually formed over millennia, making our brain considerably more substantial now than it was back then in the hazy mists of time. Our human brain is unique in the degree to which it has evolved. With its 100 million neurons or nerve cells, it has become one of the most sophisticated things in the entire universe. Its constituent parts were layered over time, and each has come to have a particular function. Today, the astonishing complexity of our modern brain sets us apart from our early lizard forefathers, and indeed every other species as well. Despite the human brain's impressive capacity, it is remarkable how our brain stem still resembles the reptilian's brain, both in form and function. It continues to trigger similar drives, instincts, and concerns to that of a lizard, stimuli that would not have been too different from those experienced by our distant reptilian ancestors. Of course, such responses were essential to our species' survival, not least because his ancient relatives lived in a much more dangerous world than the one we now inhabit. Clinical psychologist and author Dr. Chris Irons lists such primitive brain functions as the 4 Fs, namely feeding, fighting, fleeing, and, well, let's say having sex. And while on the subject of procreation, it is interesting to note that Mother Nature had reptiles adopt a safety in numbers strategy. Typically, they would produce many offspring, hoping that at least a few might beat the often daunting survival odds. This age-old approach means our primitive forefathers didn't provide their young with much parental care, and this is still the case with many modern-day reptiles. You'll probably have seen documentaries that show vast numbers of baby turtles hatching on some remote beach. Statistically, only about 1% of these tiny creatures survive into adulthood. Their first challenge is to get themselves to the relative safety of the nearby sea. However, to do so, they're forced to run a gauntlet of predators waiting to pick them off for dinner. Of course, our distant reptilian forefathers eventually evolved into our early mammalian ancestors. And as we know, mammals by definition adopt a more nurturing approach to their young. This new caring strategy served to improve the survival chances of each of the offspring, but it naturally limited the number of young they could bring into the world. Such a step change required these forefathers evolve the emotions needed to support closer parent-child bonds, and later the broader social ties of an extended family and tribe. And for this to happen, significant changes were needed in their still relatively primitive brain. So as a result, our early mammalian ancestors developed a limbic system that we've inherited from them. This system is now the part of our brain that drives emotions. It enables us to enjoy our connection to loved ones and the wider community, but it can also trigger an unpleasant emotional response when we perceive things might not be going right. For convenience, some neuroscientists now refer to our reptilian and early mammalian brain regions jointly as our old brain. Together, they support such vital functions as our involuntary nervous system and survival instincts, including the fight, flight, freeze, threat response we experience when we perceive danger. They also provide us with a range of emotions and ability to connect and bond with others. In contrast to our emotional old brain, our extraordinary neocortex is a relatively newcomer to our evolutionary history. The so-called new brain provides exceptional thinking and problem-solving abilities, and it serves to make our species as intelligent as it has become. The neocortex is a part of our brain that we employ when we're curious or creative. It enables us to anticipate, imagine, plan, reflect, contemplate, and even find purpose in life. It also allows us to observe our thought processes and be aware that we are aware. In doing so, it provides us with a unique capacity to have a sense of self. Amazingly, it seems we are the only animal with this ability. Although our brain's old and new parts can function independently, they tend to work together seamlessly, at least most of the time. A well-established feedback loop enables the old area of our brain responsible for emotions and a newer region accountable for thoughts to cooperate and harmonize. And it stands to reason that the same feedback loop system also includes the rest of our physiology. After all, our central and peripheral nervous systems, which cover our entire physical body, effectively make them an extension of our brain. So, how does it work in practice? For example, should our rational mind, in other words our new brain, perceive we are in danger of some sort, our emotional system or old brain will instantly respond, causing us to experience fright or a sense of fear. At the same time, our body will react to the apparent threat. Our pulse and breathing will likely speed up, and our muscles will become increasingly tense. Naturally, this automatic reaction is designed to prepare our physical body for whatever defensive action may be necessary for our survival. And for many of us, this fight, flight, freeze response is still all too frequently triggered, even though we are seldom in actual physical danger these days, as was certainly the case for our ancient forefathers, living as they did in the wild, so to speak. In other words, we can find ourselves in threat mode unnecessarily, and sometimes for long periods. And we don't even always realize it. The fact that we're the only species to experience chronic stress, long-term anxiety, and debilitating depression the way we do exposes what may be something of an evolutionary glitch in this feedback system. There are times when our new brain mental capacities can get hijacked by old brain passions, motives, and fears. And we can then all too easily get caught up in cycles of thinking that trigger strong feelings, and strong feelings that trigger negative thoughts, and so on. So the musings of our new brain can stimulate an unpleasant emotional response in our old brain, which in turn supports further threat-based circular thoughts. It is because of this evolutionary glitch that we might spiral into a problematic emotional state from time to time. Perhaps this is just the price our species pays for being smart. But the good news is that by training our brain in mindfulness, compassion, and other evidence-based techniques, we can enjoy better focus, greater resilience, and much improved mental health. Expect life to be different.